Okay, so we're going to be doing lead code 105, construct binary tree from preorder and inorder traversal. So you're given two integer arrays, one called preorder and one called inorder, where preorder is in a preorder traversal and inorder is in the inorder traversal of the same tree. And it's supposed to construct and return the binary tree. So we know that we can't get the binary tree just with a preorder traversal, right? So what we'll need to do is utilize the inorder array. We can't get the binary tree just using the preorder array. We need to use the inorder array. And the way we do it is we know that at each level, the root that we'll use to construct the bottoms in the preorder is from the start, right? So at each level, we set the root, right? And then we find its index within here, because that will help us determine which portions are on the left of the root and which portions are on the right, right? So here, when we grab 3, the portions to the left of the binary tree will be this side and this side. So we use an index, the index from the inorder of the root that we got here in the preorder, to divide the rest of this array, right? So let's do that in code. So we find the root for this level. So root will equal to tree node. Actually, let's first find the root val, right? So we find the root val for this level, which will be root val is equal to preorder. It's the first in the array for preorder, right? Then we create a root node. Tree node val is initialized to root val. Then we create the left. No, we find the index, the dividing index. The dividing index in the inorder array that we'll use to divide the rest of our preorder array, right? So let's call it mid is equal to, we could have used the loop, but what we're going to do it like this: inorder.index, and we'll use root val. So what this code does is it goes through the inorder and looks for the root val. In this case, it's 3, right? So it finds 3 and returns that index. So that's this index is what we're going to use to divide this, right? So we can now build our right and left nodes for this tree. So we say root.left is equal to, and it's a recursive call, so it will be self.build tree preorder inorder root.right is equal to self.build tree preorder inorder, right? So what is this? This preorder here is going to contain this part, right? Since it's the left, right? And because here, how do we know we're dividing it up to here? Because in the inorder, this is our root, right? So the left is this side and the right is this side, right? So our preorder is going to be this part, and our left side is going to be this side, and then our right side is going to be this side, for the pre-order, right? So we start from index 1, since we always use index 0, right? So we start from index 1 till the mid plus 1, because we want to include everything up to here, right? And then for the inorder, we do not want to include the mid because we already used it here, right? So for inorder, it will be from the start up to the mid, right? That will be the left side, right? And then for the right side, the pre-order will be, we want to divide it from here all the way to here. So for the right side, it will be mid plus 1 up until the end, because we want to get this whole part. And then the inorder, remember in the inorder, we're trying to avoid this part because we already used it, right? So the inorder is going to be from mid plus 1 till the end. Mid plus 1 till the end. So you need to understand in order to get these right, you need to understand the logic of us choosing the root val, meaning that when we come here, we'll start from 1, blah, 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 right? And you need to understand the logic that inorder doesn't touch the mid, but preorder will actually use the mid value as well. So after we're done with this, we return the root. So let's run this. Oh, list index is out of range. Where did I make a mistake? I seem to have made a mistake somewhere. We need to check it out. Oh, very important. Edge case, base case, right? So if preorder, if not preorder, sorry, I missed this. If not preorder or not in order, then it means we simply return none. Yeah, that was my mistake, my bad. But yeah, so this should take of n time, where n is the size of the array. But it's not the most optimal because of this, right? Because we are recreating smaller and smaller arrays, right? So the space complexity is actually n, but since we are recreating small arrays, it becomes a bit inefficient, right? So this is the solution to the problem, and yes, don't forget the base case of if either of them is empty, then you simply return none, right? So that is the solution. Next up, we're going to be doing using the post order, right? So thank you and bye.